This is a word problem which involves a balance of forces somewhat. And you can see that there's the word problem says that there is a barge. It's being towed by two tugboats. And each of them are pulling off at an angle to the actual direction of the barge. So the barge is moving forward, and the net force that's pulling it forward is 6,000 pounds. We know that some of that force is being provided by this tugboat, and some is being provided by this tugboat. And we want to find what is the force that's being applied along the tow lines. And the problem says theta equals 20 degrees. Now, notice in this picture that theta represents both angles, right, for both tugboats. One is positive and one is negative, but they're both the same, which means that what each one of these tugboats is contributing to this 6,000 pounds must be the same. So each one of these tugboats is providing 3,000 pounds of force, which is moving it that way. Now, if I look, let's say I just deal with one of these triangles. Let me draw it over here. Okay, this angle is 20 degrees. This force is 3,000 pounds, because it's just half of the total. Wait for my pen to catch up. 3,000. And we are trying to find the tension in the line. Well, that's a fairly basic trig problem there. Which trig function would we use to find the missing t? Okay, well, this is adjacent and hypotenuse, which is cosine. So we should say cosine of 20 degrees equals 3,000 over t. Right? Solve for t. T equals 3,000 over the cosine of 20. Which is 3,192. Actually, 92.53, so I'll call it 3,193. So each one of these tugs is pulling at 3,193 pounds at an angle of 20 degrees. That means the component, which is in the direction the boat is moving, is 3,000 pounds. When you add them both together, you get 6,000 pounds. The key to this problem is that these angles are the same. Right? We could still do this problem if they were different, but because they're the same, we really only have to solve this triangle once.